script book had a rhino on its cover. You know how O'Reilly comes with crazy ideas of putting animals on book covers. So it turned out that the book they published for JavaScript had a rhino on its cover. So when they wanted to create the JavaScript engine for Mozilla, they decided to call it Rhino. So the name Rhino is taken. What do you do? And everything else has to be somehow related to Rhino now with JavaScript, right? Nashhorn is German word for rhino. So that's where it came from. So this is the reincarnation of the JavaScript engine. Now, why have another JavaScript engine? The reason is this is something that's shipped with Java 8. And some of the key strengths of this is that this really is a server-side JavaScript engine. So you're able to write your JavaScript code, but you can interact with Java code if you're interested in talking to Java. So I would use something like Node if I'm writing Java script alone, or some of the other implementations, right? I could use many of them. The time I would use something like Nashhorn is if I am going to use Java along with JavaScript. I want to leverage the power of the JVM from my JavaScript code. That's when I would be using this. So this is a server-side execution engine, which means you don't have things like DOM and all that available to you to access. You don't have the window dot something to access all the things that you normally find in a browser. You don't have those things on your hand. This is really for two things. One is to run JavaScript on the JVM, and second, to leverage and interoperate with Java. That's when you would use this. One of the real powers of this is that Java has introduced Invoke Dynamic. Invoke Dynamic was introduced in Java 7, but it was rewritten in Java 8 because they found out that Invoke Dynamic is something they could actually use, not for just dynamic type language, but to program Java 8. So Invoke Dynamic went through enormous amount of change in Java 8 for that purpose. And a lot of dynamic type languages and Java 8 itself makes good use of Invoke Dynamic. Well, that's exactly what JavaScript does. JavaScript makes use of Invoke Dynamic to talk to really implement the method calls. As a result, it provides fairly efficient method dispatching. Well, what does Invoke Dynamic really do? Very short, Invoke Dynamic is kind of like a late binding, if you will. It ties it down to the code at runtime what method it wants to call. And Java 8 Lambda expressions rely on this very heavily to perform these kinds of calls. I won't talk about Invoke Dynamic anymore here, but I have a separate talk, an hour-long talk on Invoke Dynamic tomorrow, if that's a topic of interest to you. But basically, they are using Invoke Dynamic under the hood to provide this. So you can use this either as a standalone JavaScript and then leverage into Java, or you can do an embedded JavaScript, where you can embed JavaScript within your Java code. I'm going to show you both of those ways, how you can go back and forth between using a standalone and using it embedded. So, but before that, let's talk a little bit about some JavaScript fundamentals, just to kind of get an idea about some of the things we're going to be looking at and working with. First of all, in JavaScript, we all know that JavaScript is a dynamically typed language, and you can define variables. For example, you can say foo, and you can print out the value of foo. I'm using Node at this moment for a minute here, and this is just displaying the value of foo here. We can also use functions. So we can say, for example, function f1 equals, we can write a function, and then whatever we want to do within this function. So for example, I would say f1 called, and then we can display that function, and we can say f1 and call the function, and we can see the function is being executed. So that's another thing we could do. We could also use classes if you're interested in writing classes. For example, we could define a class. Maybe we'll say a car class equals function, and then within this we could define, for example, a year, and then we can say this dot year equals year. And we could also define a duration. For example, we could say in here function, and then we would probably simply say driving, for example, and we can create objects of this class. So we can say, for example, car equals new car, maybe 2014, and then we could say car, let's print the year of the car. So we could say car.year, and print the value of the year. We could also say car dot drive and call the drive method, and we could call the method. But one of the things we can do, interesting enough, in JavaScript is JavaScript has this little feature called the with. I want to just talk about that for a minute. You could say car.with, and I'm going to move these 2 lines of code within this block here into the with block and have it run. So what does this with actually do? Well, actually, this the other way around. So you pass the with and pass the car to it, and what does this really do? Well, notice here, I can remove the reference to car, and I can remove the reference to car here also. So this is a feature where you can kind of give a context to an object to run. So you don't know what year is. If I had put this code outside, it would fail. So if you notice here, if I grab these 2 and bring it outside, it fails because it doesn't have a clue what year is. But I'm moving it within the with block. So the with block gives a context of execution. So when it doesn't know what year is, it simply falls back on the car object. Similarly, it doesn't know what drive is, it falls back to the car object. So those are the couple of things I want to just mention. We're going to use some of these along the way, and that's the with command in JavaScript. Anyway, so given this, a few things, let's talk about running this as standalone to begin with. If you install Java 8, you already have a command available to you called JJS, which is really a JavaScript engine call to the JavaScript engine. So I'm going to go to the command prompt right here. In the command prompt, I'm going to say JJS, and that brings up a prompt right there. So I'm going to say 2 plus 3. You can see 5 being displayed. We are running this code within the JavaScript engine. So JJS is the little command for the tool, and I just ran it as an interactive shell right now. By just typing JS, you get a little interactive prompt. Why is that so cool? The reason it's so cool is when you type that, you get an interactive prompt. These are called as something very useful. These are called as REPL. And a REPL is just awesome. I love REPLs. REPL stands for read, evaluate, print, loop. It reads your code, it evaluates your code, prints the result, and faithfully loops back to do this all over again. So a REPL is a great tool for you to experiment, type a little code, play with it, get your code into the shape you want to, and then you can copy and paste it wherever you want to copy and paste it, and then continue with your coding. Or this can be a quick experimentation to figure out what kind of commands you have to use to bring things into shape, and you can use it very nicely. So these can be very useful for trying out commands and stuff like that. So for example, stir equals, I could say, for example, here, hello is a string I want to create. So let's go ahead and say, in this case, the string here is, let's say, in this case, the string is going to be, let's say, var stir equals hello, and I'm defining a hello string. So I'm going to print stir right here and print the value. Notice I used the command called print and not the console.log I used a few minutes ago, because I'm no longer using Node.js. I'm using the tool, the Nashorn, basically, to run this. And in this case, of course, I could call methods on the string. And for example, length, for instance, I could call the length method and find out the length is 5. So you're interacting with this right here dynamically, and this is the interactive shell. But you can also use a file that you have already written. So for example, I'm going to go to the file over here. I'm going to say print, let's say hello right here. Again, I'm not using console.log. I cannot run this in Node anymore because I'm not using any commands that Node is aware of. But notice that in this directory I have the sample.js, which is just the file that we just wrote sitting right here. So JJS and then sample.js, you can see it's running right there. So I just ran the command here using the JJS command, and we can see the output from it. Well, when you're running this, there are 2 different modes available. One is the strict mode. I really don't know what strict mode is. I guess it's a strict mode is not the other mode, because that's kind of the normal way it is actually running. But you could use the scripting mode as well. What in the world is a scripting mode? Scripting mode gives you a little bit more capabilities for writing some interesting code. For example, you can write expressions in strings. Let's take a look at an example of what expressions in strings really mean. So let's say for a minute, I'm going to say var name equals, let's say Josh over here. And so we're going to type the name, and I want to print hello Josh, how do I do that? I could say print, and then I would say, hello, and then a plus, and then the name, and we would write some code like this, and then we would come back, of course, faithfully run it. We'll say JJS, and then say sample.js, and we can see that run. I'm going to be a little lazy here. I want to run this, kind of a little automated as I'm saving stuff. So we could use some commands here to kind of look at file change and run it. I'll come back to that in just a minute. But the point really here is that if you're really looking at this, this is where we are writing a string and doing a plus and then putting the name. That is kind of boring, isn't it? You got to start concatenating these strings together. That is no fun at all. So what we can do instead of doing that is we could use a few different options. We could say print, for example. I'm going to say hello and then a dollar name. And then I'm also going to print one more time, but this time I'm going to use a double quote hello, a dollar name, right? So I've got a little bit of leverage here where I've used an expression, a string expression. This is, if you're used to languages like Groovy or Ruby, this is something you're very familiar with already. But you can do that in Nashhorn. Basically, you can specify that that's the string you want to implement. Real quick here, the single quote is just a literal. The double quote, on the other hand, has an expression in it. And so you can decide which one you want based on what you're trying to do. Are you interested in printing the dollar itself, or are you interested in printing evaluation of the expression that you placed after the dollar? So let's go ahead and try this now. If I run it with JJS, well, that's not quite helpful, right? Because I know Josh always creates trouble, and that's what he's doing right there. It doesn't work, right? But he needs a little cajoling, right? So you specify JJS minus scripting, and then you specify sample.js, and then you can see that the difference is here. So when you run it in the scripting mode, it evaluates the expression and says, oh, now I'm going to evaluate expressions. So in the top, I just ran it without the minus scripting. It took the strings literally as literals, whereas when I ran it with the minus scripting option, it said, oh, I'm going to expand the text right here. And when you use the double quote, it expanded it. But when you use a single quote, it just kept it as a literal. So you can decide whether you want string literals using the single quote, or you can use a double quote if you're interested in using expressions. That saves a bit of a typing. It also makes things a little bit less error-prone also, if you will, because it becomes a lot more easier to work with. So that is something you could do. One other thing I'm going to, just for convenience purpose, is I'm going to go back and run that code for a second. I'm going to say this is the JS file I'm interested in running, and this is something I tend to do quite a bit, and I'm going to say run if changed and call that. So that kind of minimizes my need for typing this over and over, so I can kind of sit there and type this code, and I can see the output without moving a muzzle. So I'm going to leave this right here so you can actually see that right there. So I'm going to just go ahead and save that and just reruns it. So you can see how we can see the value being displayed right here. So what did we learn so far? Well, you can have variables like name, for example, and then we can specify a plus symbol like we normally do, which is kind of old school. If you really want to do that, you could do that. If you use a single quote, you can see that it just literally prints everything in there. Or you can use a double quote, in which case it expands the name as the expression and prints it. So we just saw the expression in the string. Another of my favorite is something called a HereDogs. Now, what is really a HereDog? Well, I'm sure everybody in this room has done this at some point or the other. You want to create a multi-line string. So how do you create a multi-line string? You say string equals the first line, and then you say string plus equals the second line, plus equals. Ever done that? How do you feel after doing that? Dirty, right? You feel really dirty. You feel like you got a lot of dust on you. You go home, the kids run towards you, say, don't touch me, right? You got to go shower. That's how you feel. You should feel that way, right? Because you're putting a plus equals to write this code. That's heavy stuff. Why do you want to do that? This got to be a lot simpler than that. Well, it turns out the syntax they used is a lot like what Ruby uses. So let's take a look at an example here. So let's go back to this code and do something a little bit differently here. Let's create one multi-line string over here for a second. So I'm going to go ahead and say an expression and end here. And I'm going to go ahead and type end here for a minute. And I'm going to say right here stuff, right? That's all I'm writing, just a little stuff to write. Notice how it printed stuff, right? But let's make this a little bit more interesting, right? So we will say here, know what, and then we will specify a dollar name, and then we will say over here, owes me, or let's say in the next line, $10. Can you get it for me, Scott? Right? So now we know that Josh owes me $10. So we can get it from him. You can see that it expands it. That's a multi-line string, as you can see right there, right? So it says, know what, Josh owes me, there's the $10, and then can you get it for me, Scott? So you can see that multi-line string appears really nicely. What's the benefit of this? The benefit of this is, notice how I was able to expand and display the expression, right? So I'll give you an example of this. I've used HereDogs in other languages, and this is one of my favorite features. I normally have this bad habit of sending emails to people with their name on it. So if I were to send you an email, I would say, dear, and your name in there. Why? Because when you get an email, when I say, dear, your name, that's very personalized than saying, type a random message. Sometimes this happens, right? You even send message to wrong people, and then you wonder why they didn't respond. Even worse, why they responded, actually, right? And you want to really address to people. Well, so I have this habit of always sending email. I would say, dear Scott, and send an email. Dear Josh, and send an email. That's the way I kind of send emails. Except there's one problem. I was invited to be part of a conference as a track chair, and which means I have to invite people to be reviewers on my track. And the conference said, good news for you. We got some potential reviewers for you, and here's the list. And they gave me 600 people. Now, how do I, dear, if I start with that, when will I finish it? I'll be old and dead by the time I send email to 600 people typing their names, right? No, you don't. There's a nice, this is the mail merge, right? So there's a nice spreadsheet. So all I did was, I wrote a little code with the HereDog, and simply said, dear dollar name, and then the text that you want to appear, and that's a nice loop. And you simply loop through and generate that text, in the loop, and then once you generate the dynamic text, you stick it into the email, and then you're firing it out. Make sure you test it at least a few times before you actually fire off on the 600 people. Within about 10 minutes, I had personalized email go to people inviting them to be part of this event. And that way, when they get email, it's not a blind copy, but a very personalized email, right? So the point I'm making is features like HereDog not only make it convenient to write code, they also make it very convenient to spam people also, right? So it's a very nice feature to use, and you can generate these kinds of response very quickly. This is also very useful to create dynamic contents and then maybe insert them into databases and stuff like that you normally do, and that concept is carried over here. One of the other features I really like a lot is a feature to invoke into system-level shell. Now, after all, if you're writing code here, you could write all the code you want to, but wouldn't it be nice? So, for example, here, I could print over here and say, hello, but who really wants all this static text being displayed all the time? I want to talk to stuff on my machine. So to give you an example of this, I maintain some repositories like Subversion and Git and what have you, and from time to time, I have to dynamically issue commands to the underlying system, get the response from it, do some work with it, and then do the processing of the response. But how do you really talk to an external process? Well, if you're looking at language like Java or C#, you're really looking at several lines of code you have to write to make this work. But not so here. So notice what I'm going to do. I'm going to simply say print line svn help. Of course, it's a string at this point. If I save it, all that it said is svn help. That's all it did, right? So I just printed svn help and it printed svn help. But I don't want to print svn help. I want to run svn help on the machine and print its response out. That's what I really want to do. So I'm going to change this single quote into a little tick symbol, and that's all I did right here, and all of a sudden you can see the output is very different. That's the output from Subversion help that you see right there. So we just executed the command right here. Similarly, I could change that for those of you who are Git fans. I can change it to Git help, and you can see that that's the output from Git help at the same time. So you're running commands on the system grabbing the response from it as a string, and you can process it. So that's how easy it is to start running some of those commands from here and onto the system. So we saw how we can run that as that. Okay, that's great so far. But oftentimes, how do you run these scripts? Well, to run these scripts, what you do is you run this command called JJS. That's what I've been running here. But that's no fun if you're on the shell. If you're really writing a script, you want to be able to run this on the shell automatically. So let's see if we can do that. So I'm going to exit out of this little here, and I'm going to simply say chmod plus execute sample.js, and I'm going to say sample.js and hit the return, and it just spit on me saying, I don't understand what you're doing, obviously because it's not a bash command, and it doesn't know what to do. It just gave us an error about these stuff. It doesn't know what to do. But if I typed jjs minus scripting, for example, and then if I ran the command, let's say sample.js, it was, scripting sample.js. Let's see what happened here. Scripting. So I'm running this as a script file, and that's kind of funny how that doesn't want to run. So I want to run this as a scripting file. Let's actually remove this for a minute, run it as a regular file because I don't care about scripting at this point. Let's just say hello for a second. So I want to run this as a JJS command. So if I want to just go run it as a Nashorn command, I could say JJS and simply say sample.js file, and you can see that that's running. But if I run it as a script, of course, it doesn't work. Why? Because you got to tell the bash or the shell that this actually should be run as. So for this, what we do is a shebang that we can use. So we basically can say, hey, I want you to treat this as a shell command. So what do you normally do? You say /bin/end or things like that. So user bin end. And then what do you want to run here? I want to run the JJS command from here. So you can specify what you want to thank you. So I will make mistakes along the way, some intentional, some not, but I won't tell you which one is which. Okay? So this also ensures that somebody's awake here as you're sitting here. So thanks for correcting me there. So what we're doing here is basically typing that to say, I want to run this command in the shell. So when you run this now, you can see that it produces the output very nicely. This is another thing I'm really a favorite of because I use a lot of scripts on my machine. And sometimes I would write a Ruby script, and sometimes I would read a Groovy script. I would sometimes write JavaScript, but I don't care. I would normally name them as .sh, and I would just run them like scripts, right? And I don't care why, because when I wrote the code, it was important what language it was. But 90% of the time when I'm using this, I don't care what language I wrote it in. I want the result of it. So I want to be just getting into directories and start running it. So notice what I could do if I wanted to. I could simply move this into sample.sh as just a shell script. If you notice here, that's no shell script, that's JavaScript. And I can run this over here and get the output. And that's the benefit that you get of this, right? So the shebang basically says, I'm going to just take this code and run it and give you the result. So then you're not really worried about, this is another big advantage. Now, if you were to write a shell script, don't get me wrong, I love shell scripts. There's one problem with shell script, right? Everything works on your machine, and somebody finds out you have this wonderful shell script. And they come to you and say, hey, can I have that? You're like, sure. And then they look at it and say, oh, wait a second. Would that run on Windows? And then you would look at them and say, are you using Windows? Right? You don't want to have that conversation with them, right? You want to be friends with them still. And you don't want to have this conversation. Are you running Windows? Are you running Linux? Are you running Mac? You don't want to have that conversation. Wouldn't it be nice if your script can just run across operating systems? Well, yes, it can. So simply go ahead and write that script as JavaScript or Ruby or Groovy, and then you're writing a program in a programming language. But remember what the famous words of David West, in programming we can solve almost any problem by introducing one more level of abstraction. That one more level of indirection. Well, that one more level of indirection here, the language that translates to the underlying platform. So now you write JavaScript, you can take this and you can run it on Windows, I can run it on Mac, on Linux platform, you can run it on any machine because the underlying JavaScript interpreter gives you that buffering So you can actually go through and run this across machines. So you get that benefit rather than fighting the shell script. You can just write the code in a language and have that run. I do this quite often. Like I said, I write Ruby code often, and so that way I can run it across different platforms. And similarly, Groovy code, that gives me the indirection. And so with JavaScript also, it uses that kind of flexibility if you want to use it. So that is an example of how we can do that. I'm going to put this back into sample.js. And of course, we can still do the same thing as we did before. We could explicitly run it also, but we can also do that, as you saw, because we wrote the shebang, and that gives us an ability to do that. So all we saw so far is write the JavaScript as JavaScript, but it really ran within the JVM, and we quite didn't see that feature until now. We were just running it like JavaScript, except using this tool, but what is the sign that this actually runs within the JVM? Well, we will come back to that in just a few minutes, but let's go to the other side. We could also run JavaScript in an embedded mode where JavaScript can sit inside of your Java code and you can use that as well. So how would we go about doing that? Well, you could do, first of all, to do this, you need a couple of different things. So I'm here in Java, and I'm going to write Java to run JavaScript, right? Now, why in the world would you want to run JavaScript within Java? Well, the reason is there are several, quite an interesting set of reasons. You may be in an enterprise application where your application predominantly is in Java, but you are interested in writing a fairly lightweight, fluent interface, a DSL of some sort, and you decided you want to run this in JavaScript, or you may have a little processor that you want to run JavaScript and do stuff, or you are working on a project and you're like, you know what, I really want to process this, and somebody says, well, got a JavaScript library for that. JavaScript libraries are dime a dozen today, right? You find so many, and you're like, darn it, that's in JavaScript. Do you have one for Java? Well, rather than fighting that battle, you can just bring in that and use it right here from Java. You can use the JavaScript, and you can get the results back if you're interested. Let's play with that a little bit and see how we're going to do this. So what am I going to do? I'm going to first of all say over here, new, and I'm going to bring in the engine. So I want to really bring in a scripting. So we're going to say script engine manager, and we brought in the scripting manager. That's when you know you're on the Java side, because you have this friendly, affectionate names like manager and factory. Now you know you're in comfort zone, right? I mean, isn't that beautiful, right? This is like you're driving along, you're leaving one, beautiful city, and you're going into the desert. You get the feel that you're there. So now you know you're on the Java side. You got the manager, you got the factories, all those things. So now you feel comfortable. Yes, I know where I am right now. So let's go ahead and save that into a variable. That's my scripting engine manager that I saved it over here. Now that I have the scripting engine manager saved, I'm going to go to the scripting engine manager and say, oh, I want you to give me a scripting engine. You can say by extension, like .js, or you can say by name. And you can ask him whatever you want, and I want the Nashhorn, engine basically in this case, and I'm going to save it as, well, let's save it as Nashhorn also, right? Great, we saved it. What do we do next? We could say Nashhorn dot, so we can then ask it to evaluate. So eval, what do I want to evaluate here? Let's go ahead and evaluate a print, and then we will say over here, hello, and let's go ahead and close that. And let's close the string itself. So we're going to close that out and ask it to run that. So let me go ahead and fix that. So that's what I want to run. So we asked him to print that, a semicolon to end that, and then close that, and then close it. Well, of course, our Java compiler reminds us that we need to take care of something. I right-click on it, says, you have to handle exception. But here's the good news, right? As experienced Java programmers, we know exactly how to take care of exceptions, so we took care of that right there, right? So now that we handled that, now it's quiet, the compiler is happy, we could run it. So we could, let's say we run this and see what the result is. So I'm just running that little code, and notice that, it said hello right there, and we got the output sitting right here. It says hello. Great, that is the response from that little code. But of course, that's kind of boring. We ran a JavaScript, but I really want to talk to JavaScript like it's a first-class citizen. I know that's a bit scary, but I want to talk to it like it's a little distant first-class citizen, right? So it's kind of like the first cousin, but you don't want the cousin to be visiting too often. So you want to talk to it, but you want to send parameters to it. You want to get the result from it. How do you do all of that? Well, sure, you can do all of that if you want to. Let's take a look at some examples. However, who here gets excited about literally putting JavaScript code within Java code? Raise your hand if you do. Those guys, don't ever listen to them, right? And here's what you do. Don't go to their talks this afternoon. That's how you punish those two people, right? Bad examples, bad examples. Do we have the right to throw people out of the room from here? Absolutely. Well, okay, that guy is a little heavy, hard to throw out. Josh, maybe, with a few hands we can do that, right? Well, anyway, I'll pretend you don't exist here. Anybody with the right mind, let me put it that way, embeds JavaScript code within Java. Okay, there you go, that's the answer, right? No, we don't. Why? Because it's already painful to write Java code. You don't want to put JavaScript in there too, right? And then have all that boatload of stuff to stay with you. So what do? Well, the norm is you don't. So here's another reason why you really don't want to put JavaScript within Java. Guess why? Because if you then want to change the JavaScript, you got to recompile your code. What fun is that, right? So you want to be able to change your JavaScript, not change your Java code, simply rerun your Java code, and you want that to use your JavaScript. So what do? Well, turns out it's not really that hard to do. So let's go back to this code we wrote. Remember this code? The sample.js that we wrote. So let's go back and look at the sample.js. Let's get rid of this shebang we wrote. Let's just only have a print hello for a minute. So if you notice, it simply says print hello. That's all it contains, right? Nothing else. Well, where did I put this? I put it in the op.js directory. That doesn't have anything else in here. So I'm going to go back over here, and I'm going to simply say Nashhorn dot, and I'm going to evaluate. Well, fortunately, notice the evaluate actually takes a reader. So I can say new file reader, and the reader I want to read into is opt.js sample.js. Isn't that sweet? You can just take that file, and of course, in Java, you have to pay some toll, right? You want to do something different, you have to handle more exceptions. No problem, we are skillful to do that. So that is taken care right away. Isn't that wonderful? IDs are awesome, right? They're meant to really help us program Java in the most productive manner. So that's taken care of obviously right there. And what do we do next? Well, I want to just receive this and run it, and I'm asking it to evaluate it. So I go ahead and run this code, and of course, if the file didn't exist, it's going to complain to us, but right there is hello as the output, and we got that hello output right there from that file we just pointed to, and that works really nicely, as you can see. Great. So we saw how to run the file, evaluate it, and evaluate as a string. We can do that also. But I really want to get a result from this file. How do I do that? So I'm going to go back to the file right here. And what I would like to return from here, not just a print line. Let's just go ahead and say print line. I will say running sample. But I want to return maybe a value 42. I want to return from here, right? So return value 42. So I'm returning a result from this particular function. So we have a return value. Let's go back to our Java code right here. And let's go ahead and run this code this time. And notice, oh, wait a minute, there's a little bit of an error being thrown at us. Let's see what it is. It's complaining that it doesn't understand what a return 42 is doing right there, of course. So let's go ahead and fix that. So I want to go ahead and call maybe a function at this point and evaluate it. So let's go ahead and write this as a function. So running JavaScript sample, and then let's write a function foo, and the function foo is going to return 42 as a result. So we got a function called foo on our hand. That's awesome. So let's save that away. Let's go back here to Java code and run this Java code. You can see at this point, let's see what it's complaining about again. So it's complaining, of course, sorry. So this has got to be foo equals function. Sleeping at the wheel right here. So we wrote that as a function. So you can see all that exception being thrown towards us in the Java code by way of exception. Well, all it printed this time was running sample. That's what it did. But I really want to go ahead and call the method. So I'm going to say Nashhorn.evaluate, and this time I'm going to call the method foo that we wrote on the Java side. So I'm going to go ahead and call that method. But before I call that method, let's get back to this code, and let's also put over here print, and we will say calling foo, so we can actually see that being called before we get the result itself. So let's get back here and run this code one more time, and we can see in this case it tells us it's running sample, and it also says calling foo, so we were able to call that method and get the result. Well, actually call that method, but I want the result back. So we'll say result equals, so we're going to say this is going to be result, and once we got the result, I'm going to output the result. You could cast it away and do all those funny stuff if you want to, but in this case, I'm going to just print it, and you can see on the Java side, we simply went ahead and ran that, and you can see the output being printed 42 on the Java side, which is a result of that particular call. So you simply called eval and then captured that result into the variable, and then we just printed it on the Java side. So what did we just see? We saw how you can call into this method. We haven't quite set parameters yet. We can come back to that a little later. But we were able to call this method, and whatever this method was returning, we were able to just receive that on this side and print it, which means that you can have a nice full round trip if you wanted to, and you can pass into JavaScript, let JavaScript do its work, and then when you get back the response on the Java side, you can still use it. So it's going back and forth between the two. You may be a little scared to say, oh, wait a minute, but remember this is JavaScript, what about types? But keep in mind, this is JavaScript running within your JVM. So whatever the type is, it could be a JVM type morphed into from JavaScript. So it's really not that big of a deal as it may appear to be when you look at it. Right? That's great so far, but one of the things you want to do is you really want to call this method a little bit more intelligently than we did here. Look at line numbers 14 and 15 for a minute. While 14 and 15 worked, that is quite a bit of work as well for us to be able to call this and then get the result from here. And we again embedded that little code in there, the foo code that we wrote on line number 14. Is there a way to avoid some of those? So here's an idea we could try. So just go back and look at the code for a second over here again. If you notice, there is a function called foo that's being produced by this code. So keep in mind the function name is foo. So I'm going to go back to code right here, and I'm going to create an interface. The interface I'm going to create here is called, well, let's call it an uppercase foo interface. Doesn't matter what you call it. We'll call it as my interface, right? So I created a my interface. I'm going to create a method here, which is going to be an integer, let's say int, and the method is called foo. And remember, the interface method is called foo. The only key thing here is that the method name is the same as the name you wrote on the JavaScript side. You called it foo over there. I called it foo over here. So we wrote a method called foo within my interface. So I come over here to the eval method, and I'm going to assign what eval is giving to me in here into this eval call. I'm running the file, but I'm going to go ahead and change this over here to save it back into an interface. So I'm going to say my interface, we'll call this as interface, we'll call it as inst equals, and we'll say my interface, and we're going to save it away into this interface. Let's just start with that for a minute, right? So that's all I have done so far is just to put it into the interface at this point. It's not giving any errors at this time. So now I'm going to go back to this code, and I'm going to output right here instance.foo, and I'm just calling that method as you can see right here. And wait a minute, I got a null pointer exception. Let's take a look at what the error was. Line number 18 gave me an exception. So let's go ahead and analyze and find out what just happened. Well, in this case, we have a function called find, and apparently instance did not come back as what we expected to come back. Let's actually print the instance alone and take a look at it and see what it's saying. And let's see what the result says in this case. Of course, it's a null. Let's go back and take a look at what happened in this case. So I have a function here that I have on my hand, which is a function called foo that I wrote. And I want this function to be appearing on the side, on our side. And in this case, it should have come back here from the engine if I did this correctly. And I'm not sure why that's giving us an error. We'll try to find out. So in this case, all I'm telling it is that I want to get access to that particular function we wrote. Let's go ahead and, what did I do? The return value is what is the return value? That's correct. So let's go ahead and say this as an object. Yeah. So let's say this is object and see what happens. Good point, right? So let's go back and run this time and see what the instance comes back as. And, it's still a null. Wishful thinking, right? It didn't quite give us a result back. Let's just make it a void method for now. Let's see in which case we are ignoring the result that it's going to give us. Let's see what that tells us at the moment. Because, of course, JavaScript doesn't know that you're returning any results by examining it, has to know it. So it's still returning a null at this point. So I'm just getting that interface, and I'm trying to store it at this point from this particular method itself when I evaluate this JavaScript. So I got to go back and debug and find out what really happened. I'm probably making some mistake here while trying to run this. Well, that is our evaluation that we ran here, and that should have given us the interface that we are interested in using. Well, once we get an interface, of course, we can call the methods on it. If I went through my errors, I would be able to find it. So we can get the invocable interface. Well, once you get the interface, there are a couple of different things we need to be careful about. The first thing is your method name is going to be the same as the you are using here when you're defining it. So let's go back to this code and see if we can set this to a function foo. We're going to say calling foo. Let's just leave it at that for a second. That's our foo method that we are really using in this call. And let's go back to this code right here. Let's say, I wrote that correctly. So in this case, I got that. I'll try this one more time. So I wrote an interface. The interface well, actually, I want to do one more thing before we go further. I typically would probably put this outside here. Let's try that just as one last ditch, because this is being an internal class here. So let's go ahead and say my interface. Let me try that one last time. So I'm going to say this is my interface. Let's call it as interface. And let's say instance equals, and then my interface. And let's go ahead and say this is going to be calling on this method. Let's go ahead and print it out and see what it tells us at this point. So output, and I'm going to say instance. I'll try this one more time and see if it comes back through. Nope, that still didn't work. So in this essence, basically the idea is, and also I probably have to put this in a separate file. Potentially it's got to be a public interface. There are a few rules you have to worry about, which means I got to put it in a different file as well. But I can almost bet you that I was able to keep it as an internal to the class itself and make it work. But apparently I'm missing something here that I can't remember at the moment. Anyway, one of the things I found out was when you do this, your method name has to match the name you provide here. What if you have multiple methods available on the JavaScript side? Well, sure, you can have multiple methods here on this side as well. And as long as the method names match up, things work really well, and you can nicely provide that very easily. So you can have these interfaces built up, and you can talk through the interface if you want to. Absolutely, you could do that. So you can pass parameters to these functions as well. How do you pass parameters? Well, that's where you have to be a little bit more tricky in passing parameters. We will talk about bindings in just a few minutes. I was talking about coercing to an interface. I mentioned that it's got to be public interface. It's got to have the same method name. And of course, it can also have multiple methods. If I iron through the error, I should be able to use that. So, but what about binding variables? Let's take this a little differently. Let's say in here, I'm going to simply say, let's say var greet equals, and I'm going to write a function, and within this function, I'm going to go ahead and print over here, and let's simply say, I'm going to say hello, and let's go ahead and say plus name. But where in the world is the name coming from? Well, name is a parameter that I want to pass to this function. So you can pass parameters to the functions as well. And how do you do that? Let's take a couple of different examples and play with this. So the function is called greet over here. So I'm going to go back and evaluate this into this variable. So I've evaluated this. And now that I've evaluated it, I'm going to say over here, evaluate the call at this point. And the call I'm going to evaluate here is going to be a call to the greet method, as you would see here. And what am I going to pass to the greet method? Well, I'm going to pass to the greet method, let's say Raju here, and I'm going to run this. We are hard coding a name, but this is from the Java side, and we can decide to send any parameters we want to. And you can see that it printed that value when we passed in as a parameter right here, and that's what we passed here. However, let's change this a little bit more. I'm not going to pass the name right here at all. Now notice, what in the world is hello name? Well, that name variable is not bounded to anything at this point. So if we run this code, it is going to give us an error. So if I go back over here and simply call greet, remember this time there is no parameter being passed to the greet function, but somehow it needs to know what the name is and print it. If I run this code now, I should expect an error, and it did blow up, but I want to know where the error came from. So if I go look at where the error came from, it's not what you may expect it to be. It actually came where it said name is not defined in eval, and it printed that error message. And if we can go back and look at where that actually came from, you would notice that's from line number 18. And if you look at what line number 18 is, it was when you call this eval. Why? Because that's when you are actually running the greet method, and it says, well, you know what, I don't know what the name is. So what do? Well, we got to tell him what these variables are. This is where you can use the bindings. Now, what is a binding? A binding is, it's kind of like you give a context. Now, imagine, here's your JavaScript code that's going to run, but you nicely provide a context to run, and you say, in this context, I'm going to define whatever you need. So when you run this code, it can rely on this context to provide those variables. So the idea really is, what is this kind of context we are talking about here? It is nothing but a hash map. So as long as you can define hash maps, you can very readily use it. So let's take a look at an example of this binding that we can use in here. So I'm going to go back to this code, and I'm going to say, first of all, a method called getBindings, and I can specify a scope for the bindings. So what is the scope I'm going to specify for the bindings? Well, if you look at the bindings, getBindings method, there are a couple of different bindings you can provide for this. And this binding is going to be in a script context, and you got two different bindings available to you. The first one is called a scope context dot global scope. Another is called the engine scope. What in the world is that? Well, the word global is not what you may think as global. Remember, you have a scripting manager. Remember that guy, right? From the scripting manager, potentially in an application, you can invoke multiple scripting engines. So you may have a JavaScript engine and a Groovy engine. Who knows? You have multiple engines. So think about this application in the architecture point of view, that this application is sitting up here, Java application, but it's got one engine here, another engine here, but all that is running within the application itself. And for whatever reason, you have a variable here and the same exact variable over there. So you're saying those two variables are one and the same within these two scripts. How do you tie them together? That's your global scope. The global scope is at the top level, whereas the engine manager scope is, you have variable only within this engine, and this variable is a different variable only with this engine. They may have the same name, but they are two different variables inside their own engine, right? So that is kind of what global versus the engine manager means. In this case, I don't care about global scope. I'm just going to say engine scope and ask for it. You can also ask it to give you an object by asking to create bindings. So you're saying, okay, that's great, but I really have an application where I'm going to keep rerunning this application over and over and over. However, the first time I run it, I want a group of variables. Second time I run it, I want a group of different variables. Why would you do that? Well, maybe in the first time you want to run it in a test mode. In the second time, you may want to run it in an integration mode. Well, but how do you really change between them? Very easy. You create your test binding and production binding. And the first time you attach it to a test binding, the second time you can attach it to an integration binding. And how do you flip back and forth between them? Well, you can pretty much get a binding, and you can tell him which binding to use at that point. You can create your own bindings. Once you create the bindings, you can set the binding before you run the code and say, run the code in the context of this current binding, and you can do that for sure. So now that we have done this, I'm going to go to bindings.put, and what do I want to put? Remember, the name of the variable is called name, and I'm going to specify here, over here, let's say George over here, and I'm going to run this time. Notice we are calling greet with no parameters at this point. We haven't given any parameters to that, but notice that the output says hello George, so we can see how in this case we were able to attach a binding to this variable and have it run from within this context. So you can change the binding, of course. You can have multiple different collections. It's just a hash map, and then by flipping the binding, you can run the same code with different attached variables in these contexts. Okay, so that's good so far, but let's switch gears one more time. So we did a couple of things, right? We first ran JavaScript as JavaScript. That's all we did. And the second time we ran Java with embedded JavaScript. Now we want to do the other way around. We want to embed Java within JavaScript. Now, why would you do that? Well, if you want to create a Swing application, for example, from JavaScript, right? Or you want to talk to a Java library, but you want to write JavaScript code to talk to Java library, you can certainly do that as well. So let's see how we can do it with an example here. So I'm going to go back to this code right here that we are writing. This is the sample.js, And I want to just rerun this code over here, and we want to take a look at what it produces every time I run this. So I'm going to just go ahead and run this code. And what am I going to do here? Let's get started with a print again. Let's say hello like we wrote before. This is purely JavaScript at this point that I'm running, and it printed hello. But what I would like to do this time is I'm going to go back here and say, for example, new java dot, let's say lang dot, what can I say here? Well, let's say java.util dot, let's say array list, whatever you want to create. Let's say java.io.file. And what file am I interested in really reading at this point? How about the same file that we are dealing with, sample.js? So I'm going to specify the sample.js file itself that I would like to read right within here. So I'm going to specify java.io.file sample.js, and I'm asking you to bring it in. And notice what it's doing. Well, of course, in this case, I ran it as a string, but I want to go ahead and remove the string part right here. So remove that and just say remove the new string around the new. And now we are saying new of an object, and we are creating an object right here. Notice what the output said. The output said sample.js. And how did it know that it's sample.js? Because it is a Java object. And you can also say dot absolute path right here and save it. And what does it say? It gives me the path. You probably noticed one thing and said, wait a second, I know Java, and there is no such thing called absolute path. You have to call what? Get absolute path, right? Why do you have to call a get absolute path? Well, because Java has the getters. Remember, there's one concept in Java called Java beans. Remember Java beans? Do you know the story of Java beans, right? Java beans is a very sad story. The day that Java was created, they said, we got Java beans. The Java beans came around and said, what are we? Well, you guys are special. You are Java beans. And Java beans went and partied that night, came back late in the night and said, we are still special, right? Of course you're special. And it went and partied a little bit more and came back and said, how are we special? Well, you're Java beans. You got properties. And they had more fun. They came back and said, one last question. We have properties. We are special. But how do people access us? And Java said, using those stupid getters, of course. And they've been in depression ever since, right? Because they're not, after all, special like they are supposed to be. Well, JavaScript notice treats it with a special respect. It says, you know what? You really are a bean. I can just call your property, and it'll turn around and call the getter automatically behind the scene. So we are able to call absolute path, and it was able to turn around and say, call get absolute path. So that really is a bean that you're able to call behind the scenes. So that's what we did. We just called it from here, and we used it. But there is one small consequence here. Notice how I had to give the full path to this to refer to the file that I'm interested in calling into. And that is a bit of a pain in the neck, because every time you have to call it, what do you have to do? You got to give the full name. This is like, remember the time you were in elementary school, and somebody came to you and say, what's your name? What did you say? Your entire full name, which can be really painful because some of us have very long names, right? And what do you do when you grow up? You just use a nickname and get away with, right? Because you're tired of saying your own name, and then you watch your children do the same thing afterwards, right? That's kind of like growing up in this case, right? I don't want to say this full name. I just want to give this name and be done with it. Well, there are a couple of different options you have available to you to get around that. So what are the things you can do? Well, we gave the full name right here, but we'll come back to that in a second. We are embedding Java. We want to call a static method. How do I call static methods? Well, let's give it a try right here. Well, let's think of one static method I want to use. Oh, let's say over here, I want to say java.lang.string a value of, let's say, 7, right? So that is going to bring the value of 7. Oh, wait a minute. So this is going to be a value of a string dot. Oh, you could say toString, for example, whatever it is, right? If there's a static method, you can call it. Well, that's exactly how you would call static methods, by specifying the name. And if I know what static method to call, I would call that right here and specify that. I thought value of was a static method. And we could say, hello, for example, right there. It's a string I'm passing to it, and I would want to call this. Oh, I know what the problem is. I'm not running it properly. There it is. It said hello. So notice, go ahead and say I want to change it to a 7. So I was trying to run it as node at this point. So I'm saving it as 7. You can see that 7 is being printed. So right there, I called a static method. That's a way to call a static method. You can also create instances. You just saw me do that. We did a new file from Java.io file. But I want to reduce the noise of the full qualification. One thing you could do is you could use an alias very easily. So how do I define an alias? Well, I could do something along these lines. I can go back to the file class that we wrote a minute ago. And notice in this case, I said new file for this purpose. And the new file is going to be java.io.file all the way through to call into this. And we saw this at play a minute ago. But what I want to do is I could say, for example, var JIF equals, and then we could say java.io.file, and then we could try to say new of GIF over here and see what it tells us. So let's come back to this code right here, and we will say GIF and see if you take that, right? So what did I just do? I did exactly that, right? I defined an alias for it. If you really want to define an alias, be a little kind, right? Because other people reading this code will not understand. If you really go about, what if you say J1 and make this J1, is the code going to work? And you can see in this particular case, the code did work. But however, a rule of thumb, you give these kinds of arbitrary aliases only if you hate the people that you work with, right? Otherwise, give names that others can actually understand and maintain it. So that's one way to write it. An alternate way, what you can do is you could say, in this case, let's say, classes, we'll call it as package over here, PKG, equals, you can use a Java importer. And in the case of Java importer, you can specify what you're importing. I want to import java.io, and you're bringing in a Java importer at this point. Well, once you bring in a Java importer, what can you do at this point? Well, you can say, remember that with we talked about with the PKG, and in here you can simply say new file, and then you can specify the file name sample.js that I'm interested in, and then I'm going to get the absolute path from here, and then I want to display the absolute path, so we'll call it as print over here, and we can display it. So this is a little bit more civilized. You just do a Java importer, and then you can use the with, and then within the context, you can readily use it. So we're using the JavaScript concept we talked about earlier. So we saw how we can use Java importer. How about dealing with overloading? Well, the good news about overloading, it just works. So if you remember, Java has overloading. So you can have multiple methods with the same name, but a different signature. We also know one more thing, that JavaScript is dynamically typed. And another thing, JavaScript does not have function overloading. But it is smart enough to say, based on the type of the object you're passing in, it resolves and calls the appropriate method for you automatically, so you don't have to worry about method overloading. But if you do really want to worry, there are some people like that, right? But I still want to worry. Sure, you live in a free country. You can worry about things if you want to. And what you can do in that case is, there is one interesting feature in JavaScript. And that feature is, if you have an object, let's say, for example, you have an object, let's say var stir equals hello, you can call something like this. You can say, stir.length right here to print the length of some stuff, right? You can call the length method like this. But on the other hand, why didn't that work? So, var. No, I don't want to write Scala right now. Okay, so you can see how we can run that. But you can also do one other thing in JavaScript, right? You can take that away as a little square bracket, and you can send it as a property if you're interested in. You could do something like that. Well, that's exactly what you can do here too. You can specify the type information right here of the method you are interested in calling into Java when the method is overloaded, and it'll use that information as a hint for the type and make the resolution. That's how you specify. You can say a method that you're calling, parentheses, and the type, and it knows what you're calling and will dispatch it for you automatically. A couple of things I want to just mention quickly here before I wrap it up is, you can define a Java type object, and then you can get access to some type information, and you can go back and forth between the Java type and the JavaScript type, which is kind of oddly named here as static, but when you say .class, it gives you the Java type. When you say .static, it gives you the JavaScript type. You can go back and forth with it. Similarly, you can use lambda expressions to call into it, and there's two ways to do this. If you want to call a method into Java, you could use a full-blown Java syntax where you say function parentheses, curly bracket, implement the function in full-blown, or you can use the standard lambda expression which is coming to JavaScript in the next version, which is simply say function parentheses, variable name, and then you can just drop the code one-liner You don't have to put a return statement, and you can write sweet little Lambda expressions there. So to wrap this up, what I want to talk about here is that you are able to go back and forth between Java and JavaScript, and the main idea behind this is to really interoperate between Java and JavaScript. If you're only interested in JavaScript, nothing to do with Java, I see very little reason to really use this unless you say, well, this is actually better in performance, which is kind of debatable because I'm sure there are different solutions out there and you can evaluate. But the point really is that this gives you this interoperability if interoperability is something you are really interested in. Take a look at what Nashhorn provides for you, and then you can make use of it and benefit from this interoperability between Java and JavaScript. And the benefit in this case is that you are actually getting good performance for JavaScript also because it uses Invoke Dynamic to optimize the code. And then, of course, we saw how you can pull things from a file and execute it instead of just raw embedding within the code itself. That is all I have. Thank you.